Let me
try sharing. Host disabled participant screen sharing.
Okay, then I'll just make you host.
Gotta love security. There we go.
All right. If you don't mind, I'd like at least one more minute just to let the stragglers come in, and then.
Absolutely. It looks like there are 4 people entering the waiting room.
Oh, now waiting room privileges are now sent over to you. My apologies.
Of course. That's all right. Here, I'll give you back co-host and see if that works.
It does allow me to
Yay.
do that, so that's great.
Zoom is always a little odd. Let's see, and there's something in
Alex,
chat.
you were made co-host. I apologize for that.
Yeah, okay. I mean, I wasn't gonna argue with the extra power, but
Oh, it might go to your head though.
Do you have a presentation for us?
I do. Can you see it?
Oh no, I was asking Alex,
Oh,
who is the
Alex.
co-host, who's
Oh,
accidentally the co-host.
yeah, sure. I'll throw something together while Tony's going.
it's a night of improv.
And Tony, you are okay for me to record this?
Absolutely. I'm recording it, so I don't know why you wouldn't either.
Recording in progress.
I mean, I could stream it on Twitch as well if you want. So do you want me to get started now?
Yeah, I'll just do
Okay.
a quick intro and then.
Great.
So, welcome everybody. Welcome to our third research talk of this series. So I'm very excited to introduce Tony Mason. Tony is the answer to many of y'all's questions that begin with, do any OMSCS students end up going off to PhD land? And the answer is yes. Tony graduated in 2017 and is now at the University of British Columbia. And actually, from my understanding, did some of his PhD work was inspired by some of his work that he started while at Georgia Tech under the direction of our lovely David Joyner. But he will be able to speak more about that in depth and field questions. So I will turn it over to our host for this evening. So take it away, Tony.
Well, that's great. I'm happy to answer those questions, but first I get to bore you with a discussion of my research. So um, the motivation for this that Nick was referring to is I took the HCI class from David Joyner, actually the first term that he taught it. And one of the interesting slides in that was a whole discussion about how the file folder metaphor came about. And this had been something that had been bothering me for a while anyway. And I don't know what it was, but it sparked uh, this question that I asked, which was, can we do better than filing cabinets? And as it turns out, I think we can do better, and I think we can do a lot better. But much of the challenge involved in this is thinking about how do we shift the paradigm? How do we look for things differently? And actually, I'd rather emphasize how do we find things differently? Because one of the interesting things that happens when we start looking for our own data, we're not talking about searching the internet. We're talking about the stuff that we create. As you keep going through life, you collect more and more of these files that you've created, and you come up with these questions that say, okay, I know that I shared that with somebody, or I worked on that 6 months ago, or 2 years ago, or a decade ago. Where is it? A lot of the emphasis in my community, in the systems community, has been about making search work really well. And you can think of Google, for instance. Google inspired an awful lot of the thinking and the work that's gone on in search, but it's not the only kind of search we do. When we look for something that is our own data, what we're actually doing is not really a web search style interface or web search style behavior. What we're really doing is looking for something that we created, something that we know more about than just a generic indexing system would. But when I go looking for it, I don't want to think about search. I want to think about finding because I want to find this thing. I don't know if you've ever experienced this challenge of saying, where did I put that? One of the important points to take away from David Joyner's HCI class is we're supposed to be making a human computer interface that helps humans, that makes it easier for us to perform our own tasks. So that's what I'm going to talk about. I'm going to talk about my research. There is, in fact, a big challenge in this space, and that is we actually can't find things. It's not unique to any particular field or any particular individual. I occasionally run across people who either haven't collected enough stuff to not be able to find it, or who are super, super organized and they curate everything and they make sure that they can find absolutely everything. It's sort of like going to the house of someone you know whose house is absolutely, completely 100% organized. And then there's the rest of us who are maybe a little less organized than that. One of the fields that I drew inspiration on in talking about the scope and size of the problem is the digital asset management field. Digital asset management are the people who create things that we use to produce visual materials, websites, games, videos, animation. It's quite a large field. This statistic is one that somebody who works in the digital asset management field cited in a recent book that they wrote, and I've had some interesting conversations with them about this. 25% of the time is actually spent looking for or recreating digital assets. And what I find really surprising about this, it's a community that makes their money on being able to create and reuse these assets, yet they can't find these things even though they have better than average tools. It actually turns out this problem generalizes all over the place, and pretty much every time I turn over a rock, I find yet another example of someone saying, well, I couldn't find that, so I just simply went and did it again. I don't know if any of you have experienced that particular problem, but it is a very real problem for a lot of people. Hopefully you're one of the lucky people that doesn't struggle to try and find things. We end up with things like this. Desktops where everything is stored on top of the desktop. I don't know if you have any friends who have desktops that look this messy or this bad, but it happens quite a lot. And this is a sign of a problem. Users struggle to find their things. They put stuff on their desktop so they can find it again. It doesn't have to be somebody who's old and not familiar with a computer. Eventually, you collect enough stuff, you really don't know where everything is. I've been working with my own data set, and I have about 17.5 million files. That's not small. It's scattered over multiple machines, and it's challenging to remember where things were. I know there's duplication in there as well, but I couldn't tell you exactly what it is. This problem is exacerbated by the larger tech community in that we keep making it essentially free, not quite, it's an epsilon band around zero for cost, to store everything. But the cost of curating it, the cost of going through it and getting rid of it is actually fairly high. Most of the people I know have phones that are filled with pictures, and the only time they actually go and delete any pictures is when they run out of space. And sometimes it's easier just to go buy a new device with more storage space because it takes a lot of time, and you run into this problem that you are afraid that you're going to miss something, you're going to throw something away that you might actually need. And it's not like physical hoarding. This is digital hoarding. It doesn't really clutter up your universe, except making it difficult to find things. So here are some real hard numbers. Cloud storage growth itself has a 185% I'm sorry, that's 18.5%. I forgot. The decimal place got missed there. 18.5% consolidated annual growth rate. Yeah, that's a lot. that means it's literally just keep chugging away. Most of this data is actually unstructured, i.e. files in random and sundry locations, not in databases. Databases do a really good job of making it easy to find things. File systems do kind of a sucky job of doing that. In 2024, the current estimate is that we will produce about 147 zettabytes of data, of which roughly 90% is going to be unstructured data. So what is that? 125, 126 zettabytes. I don't know if everybody knows what a zettabyte is, but zettabyte is 1,024 exabytes, and 1,024 exabytes is, or 1,024 petabytes is an exabyte, and 1,024 terabytes is an exabyte, or a petabyte. Good lord. So it's a huge number, and at the rate we are going, we will exceed the 1 yottabyte number, which is the next suffix up for large numbers. And I don't know what we're going to do when we run out of yottabytes. There's an ISO committee that adopts these things. So the ISO committee on absurdly large numbers will have to meet and come up with yet another value for us to capture what's really going on. A big challenge in this turns out not just to be how much storage we have, but the fact that our storage is fragmented. We have distinct interfaces. I don't know about you, but I have things stored in Dropbox, OneDrive, Google Drive. I use Sync as well, which is less common. iCloud. I didn't know it until I started doing this research that iCloud doesn't have any search facility. iCloud relies on your local device to do the search, so everything has to be resident on the device in order to search iCloud. I was like blown away. Who knew? It's been an interesting outlier case in much of the analysis I've done. Applications often act like storage services as well. So you can share files with people through Slack or Discord or Teams. We attach them to emails as attachments, and often the email systems store the attachment separate from the email it came from. I don't know about you, but there are many times I've wanted to be able to take a file and say, show me the email it came from, because I need to respond to it. And that was 3 months ago. Our systems don't have the ability to do that. A big, interesting observation that is not in the systems community, it actually comes out of an HCI community, is that we're missing crucial context when it comes to finding personal data. There's a woman who completed her PhD in 2019, and I've had some exchanges with her about her work. And what she found was that by keeping track of other information about what else you were doing at the time that's completely unrelated to the object itself, but rather relates to how you used the object, how you interacted with it, what else were you doing in the world, that it significantly improved search outcomes. Now, you remember I said I'm more interested in finding than I am in search. Search is a tool for finding. It is not an endpoint. It is not the primary focus of my research, and I don't think it should be the primary focus of the community at large. There's also an interesting challenge here in that, okay, so great, we've got this cool user context. We could start storing that and giving it to our storage vendors, but I don't know about you. I'm kind of uncomfortable with giving my location information and my email data and my meeting schedule to Google and Microsoft and Dropbox and Salesforce, aka Slack, or Discord. So how do I avoid sharing my personal information? The storage systems make this problem even worse. They have no uniform search interface. We did a very simple experiment. It wasn't even my data. It was somebody who works for me, and he's a relatively new graduate. And I said, take your data, upload it into a couple of different cloud storage services, and only upload exactly the same set of data, and then do some searches. And I thought the searches were kind of strange because they're not the searches that I would have done, but that's the beauty of this. Everybody searches things differently. So he has a degree in medical anthropology. And so he was searching for things that he knew were from his classes, from his classwork. And he used different specialized searches, nothing fancy, 39, ANT 39, ANT 394, looking for a particular class. What absolutely shocked me is that the number of entries that came back from each of those searches was completely different. I was blown away. Well, no wonder nobody likes to use search. We don't even have any commonality. We have no reason to understand or expect what we're going to get back when we ask these questions. So, what's the point? Okay, well, fair enough. I started digging around. I said, how do I find out as a user? How do I find out what the search interface is? It turns out it's in the developer documentation of the APIs that you use to access these things. That's not what I expect users to be looking at. So search by itself is actually not well implemented to solve these problems. The tools that other communities, I'm in the systems community, HCI, human computer interfaces, information retrieval, and personal information management, have all been looking at this problem for literally decades. There is work stretching back into the 1980s that says the hierarchical file system sucks for lots of people. And these communities have proposed lots of different ways of doing things better, but all they do is say, let's just scrape some basic data, do some indexing, and see if we can come up with a better answer. They don't say, how do we actually bake this into our systems? How do we make this part of the computer in the way that we store and organize data? How do we allow for dynamic events and dynamic operations? The biggest thing I've also seen is that indexing ends up being completely separated. So if you have, maybe you're a Mac user, so you've got Spotlight, but it only indexes the things that are on your local machine. So if you want to look for it, and you don't know if it's on your Google Drive, OneDrive, Dropbox, your local machine, or some random device from 6 years ago. Ada Gavrilovska, who I still work with, she's a co-supervisor on my PhD actually there at Georgia Tech. She says she keeps all of her old laptops and she copies the contents of the old laptop to the new laptop, but she keeps the old laptop just in case there's something that she missed. So we end up with distinct indexes. And what that in essence means is even if we do want to use search, we have to go to each individual search location and perform this search, which of course doesn't return the same results to us. So we're kind of left going, this doesn't really work very well. The approach that I've been looking at, because it's sort of the end game of my research, is what I call the Unified Personal Index. In Unified Personal Indexing, what we actually do is we say there's no commonality in these search engines, or very little commonality. There's no agreement on what it means to index things, to how things are searched. So what can I do with this? Because frankly, this is a very hostile environment. What am I able to do with the minimum amount of information? What's the name that somebody gave to this file? Well, and I can tell you, I just got done indexing my Linux machine earlier today and found that there are 48 files that have names that are not representable in UTF-8 encoding. I was like, what? And I go and I look, and it's because it was a Git repo where someone had imported names from a Windows system into Git, and I was doing an analysis of this on my Linux box, and so it has UTF-16 characters. It has 16-bit Unicode characters that are just not expressible in UTF-8. I was like, wow, that's kind of funky that it's this complicated. In unified indexing, what we're really doing is gathering the information that we can, extracting what we know is there, and typically we end up doing this on a per storage source, and then we normalize the data. So, okay, great, this one's using Unix timestamps which start on January 1st, 1970. This one uses a MS-DOS epoch. That's what FAT uses, for instance, and FAT's still around. People put it on USB sticks all the time. That starts January 1st, 1980. And then, of course, the NTFS folks decided that the real beginning of time was January 1st, 1601. So I can't just take a timestamp out of the stat information that I get back and know what it means. I have to know what it's relative to. So how can I deal with this in a unified index? Well, I have to normalize the data. I have to put it in a format that I can actually use. It's a lot of engineering work. It's not really an interesting research question or research problem, but it is part of demonstrating that a unified personal index actually can provide us with significant benefit, and that it's something we can achieve and we can do it without it being too excessively expensive. This is what the systems community likes to do. We like to build big projects that and then measure them and say, gee, is it worth it? So a huge benefit from an HCI perspective, and every time I talk to the HCI folks about this, they think it's really cool. It's a single interface. Yeah, maybe you end up using a search tool, but at least you've only got one search tool, and I can at least explain to you how to use it. A big impetus in the last year in my work has actually been how can I take large language models and merge them in with this? Because it turns out that large language models are really good at taking natural language queries, like a search that you could put in normal uh, human language terms, and converting it into something that's actionable as a search against a database. In my case, it's GraphQL searches against a graph database that I'm using for the indexing. The other thing to keep in mind here is that since this is a personal index, it has personal information in it, and we keep it close to the user, under the user's control, so that you don't have to share that sensitive data. One of the reasons I mentioned that is because Dropbox has actually recently been doing a lot of work to augment their own search facilities and search mechanisms by adding these AI agents, which allow you to do indexing. The problem with that is, of course, you're now sharing increasingly personal information with them. And I'm sure you all trust the uh, good intentions of corporate storers of your data to share even more sensitive information because they couldn't possibly ever accidentally release it or deliberately sell it. So in unified personal indexing, I have this big bar. I can't quite see what the slide says, but at any rate, oh, it's over here on the other one. Multiple monitors. There we go. In unified personal indexing, the indexing is done at the time the file is local to your device. So this is an interesting observation here. Stuff that's in the cloud is actually really hard to index because it means you have to pay the bandwidth and the resource consumption of grabbing that file, bringing it back down locally, and then indexing it. But those files started on your device at some point. So, because I'll tell you, I don't want to download my 17 million files from any of the cloud storage services. It's going to take a long time and it can be very expensive. Every time I have to set up my Dropbox again, Dropbox complains to me because I have about 1 million files in Dropbox and it doesn't want to sync all of those files all at once. Dropbox is a really good example as well. Both OneDrive and Dropbox on Windows, at least, actually do sparse they do sparse filling of the files so that you can have what looks like the file on your local machine, but it's actually not there. What's there is a stub. If you access that file, it will go fetch the file for you on demand from the Dropbox service. But you can't index it. You can't index the contents of it. You can't do anything with the contents because it's going to recall the file, and that's going to be, again, cost prohibitive. So the right time to index these things is when they're local to your device, typically after you're done dealing with them. We don't have to do that indexing immediately because it turns out that humans actually will remember the files that they touched 5 minutes ago because it's still in the short-term memory. It's the things that I touched last week or even yesterday. But waiting 20 minutes to go and do that indexing allows time for the storage to settle down so we don't waste a lot of resources in indexing things that are going to disappear quickly. It does allow us to integrate what I call extrinsic metadata as well as intrinsic metadata. So intrinsic metadata are things that are related to the files themselves. That can be a checksum of the file. So we compute checksums of what's across the data of what's in the file. And some of the cloud storage vendors actually manage and maintain those checksums. Turns out they don't actually store the same checksums. Dropbox doesn't compute checksums the same way that Google does. Microsoft actually dropped computing checksums in July of 2023 as they tried to merge OneDrive with SharePoint. So one of the interesting things about having these different checksums is it means that I can't actually tell when files are duplicates across storage services. But Turns out it's really cheap to actually compute a host of checksums when the file's local. I can actually do one I/O, compute multiple checksums in parallel, and store them all together. And suddenly I have the ability to associate a SHA-256 checksum with a SHA-1 checksum with an MD5 checksum. So I can now see similarity, identical similarity, across storage services. Well, that's kind of cool. It's just a little thing, but it's an example of the kind of intrinsic data I'm talking about. A lot of what ends up happening with intrinsic data is semantic analysis. So if these are text files or things that can be reduced to text files, there are entire services that will take the file, scrape it, put the text into an inverted index, and allow you to do searches on the text. But what if it's not a collection of text files? What if it's a collection of video files? Well, now we have classifiers for that. I actually spoke with somebody who collects sounds, like instrument sounds and natural sounds, because he's a sound engineer. Those are his digital assets. And he has ways of classifying those and grouping them up and associating them and extracting semantic information from them. I was like, that's really cool. Wouldn't it be nice if we could have a system that allowed you to extend it to extract that semantic information, store it in the index, and let you go and say, okay, I need sounds of thunder, and have it show you the 36 files that you have that have different kinds of thunder sounds in them. You can do things with timestamps as well. Those are inherent in the metadata of the files themselves. But as I mentioned, we have to normalize that. But there are the more interesting things which I think are extrinsic. There are temporal relationships where I can actually see that, hey, look, I was listening to that song on Spotify at the same time I was writing that code. Show me the code that I was writing when I was listening to this song, or show me the files that I shared with someone last week when I was meeting with them. Right now, we do not have any mechanism for being able to answer those queries in any of the systems that I've looked at. And I've spent many years looking at these. This is associating personal activity data with storage data. Personal activity data could be your location. It could be your meetings. It could be the websites you visit, the music you listen to. There are mechanisms for detecting mood through the camera on your computer. And there's a separate body of research that says the way you organize things changes depending on your mood. So knowing what your mood was could actually make it easier for the system to find what you're looking for. This also allows us to do personalization or customization. One of the more intriguing ideas I have here is that it would be really great to build, in essence, a recommender system, what I call a personal archivist that learns how you search for things and how you organize things, and then uses a feedback model, like a GAN model, where the utility function measures two things, which I'm going to be mentioning in a minute. One is, how often do you abandon a search? How often do you fail to find something? And then how much time do you spend finding things? So I'd like to see both of those numbers decrease. I'd like to see the abandonment rate go down, and I'd like to see the amount of time you spend in finding activities go down as well, because that directly equates to increased productivity. So the research challenges here are evaluating the viability of this. Okay, what's the cost associated with this, and what's the utility? Why would I actually want to spend my resources in this way? Part of my motivation here is I can't answer all these questions, because once I can show that there's at least some basic utility, I can say, but look, there's all these other things that we could explore as well. And so part of what I'm trying to do are build abstractions, because this is what we do in systems. I'm trying to build abstractions that would allow someone to come along and say, I want to build a semantic transducer that classifies sound. And you can go to Hugging Face and find that there are classifiers that actually do that. And so I'd love to be able to just plug that in so that it can analyze things that might have sound and put that information into this index, into the database, so that now we can use it when we go searching. It also provides us with a single coherent interface. So it's a front-end facing interface that allows us to build both traditional tools like search, but also more interesting tools like this personal archivist model that I like to see. And that's very powerful, because we know that having uniform interfaces actually enables a lot of innovation, as long as the interface doesn't suck, of course. So the research questions that I look at are really very focused on what I'm proposing doing. Does the Unified Personal Index improve finding outcomes? Does the abandonment rate go down? Does the time to successfully find it decrease? In other words, if I used to spend 3 minutes doing this and now I spend 30 seconds doing it, I've saved 2.5 minutes. If I do that 4 times a day, I've saved enough for a coffee break. This is great. And over time, that starts to add up. And then the more interesting, the harder question to answer, and it's a more open-ended one, is does the Unified Personal Index allow me to build interesting new tools and develop new techniques that make it even easier for me to find things? The second research question that I look at is really related to search. I'm not a big fan of search, but I use searches to drive the research to say, what do I need to demonstrate, particularly to demonstrate that utility I was talking about before. Show me files that I shared with Aki last week represent some sort of both temporal and personal information. Aki's somebody I know, and last week is a particular time. Okay, fine. Time's already there. We've got timestamps on files, so that's there. But my storage system doesn't know who my friends are. And I'm not sure I want my storage system to know who my friends are, but here we go. That is a legitimate kind of question. Show me files I created last year when I was in Udapur. Okay, now we have temporality, but I was kind of vague. Last year, well, that would be anywhere from January 1st to December 31st, 2023. That's a pretty broad number. It's not going to narrow things down very much. The location helps more, maybe, assuming that I'm not in India going to Udapur all the time. And it has an activity associated with it. I created these. It's not that I looked at them last year. It's actually that I authored them or I created them last year. And then I have to look at what is the cost of these. So how does it perform? I have basic queries, very basic queries going, but what's really fun about it is that it did things that are just astonishingly fast to me. Actually, one of the queries I did is related to the graduate introduction to operating systems course, which I'm still involved in, and I have literally thousands and thousands of copies of a file called handler.c. And so I asked my index, I said, show me every copy of handler.c I have on my computer. And it broke the web browser because it returned so many records that the tab in my web browser, and I tried multiple browsers, it broke them all, couldn't handle the amount of data that came back, which I thought was pretty cool. Smaller queries didn't take very much time at all. I've done a fair amount of forensics work, and in forensic analysis, sometimes I end up trying to figure out where these files are located by name, because I can see there's a reference to this name, and I know somebody's using a list of directory paths to search, like a C compiler will look for header files in a variety of different locations. I can type the name of that header file, and it will tell me, oh, it's in these directories, and it did it. The database reported that it did it in about 7 milliseconds. But I can tell you that when I've had to do this from the command line on my Linux system, I use find, and it doesn't happen in 7 milliseconds. It doesn't happen in 7 seconds. Usually it takes a couple of minutes for it to walk the entire disk to find that. So, okay, simple query, absolutely. Working on making more complex queries, but it helps me establish the fact that, hey, there is at least some utility here. I have to demonstrate enough to convince the community that this is actually worthwhile, because just one kind of search isn't enough. The third research question that I have is the cost-benefit ratio here acceptable? What is the cost of collecting this metadata? How much does it cost to maintain it? How much does it cost to access it? Because if this requires that I go out and buy another 4 terabytes of storage for it, I'm not very happy with that. On my local system, I have 40 terabytes of storage, and currently my database is about 20 gigabytes. I haven't done anything to really try to slim that down. I basically just said, hey, I don't care. 20 gigabytes out of 40 terabytes I can live with, because that's a tiny fraction of 1%. But I'll look at other configurations. Not everybody maintains 40 terabytes of storage space, but these days it's not uncommon to find computers that have multiple terabytes of local storage, a lot of which doesn't get used. So my artifact, the thing that I'm building in order to answer the research questions and demonstrate my thesis, is what I call Project Indalico. And it is built on top of the ArangoDB, which is a graph database. I have indexing agents that know how to look at storage and figure out what's there and then extract information for it and put it in the database. And then I also have a separate framework for activity context services. So we have activity data providers. Where are you? That's an activity data provider. So periodically I can update the system and say, this is where you're currently geolocated at. What are you doing? What music are you listening to on Spotify? So you can build a little agent that says, here's the current music I'm listening to on Spotify. So you have time series data there. You can read your meeting calendar and say, well, you were meeting with so and so based on your meeting calendar. You were in a Zoom meeting with Nick from, I don't know, whatever time it is for you to whatever time we finish. And you'd be able to use those things to augment the index to make it easier for us to use these contextual clues of what we were doing when we were working with these storage objects. I put a couple of links in my slides. I can hand those out in case anybody's ever interested in it. You can actually see the code. It's some disgusting Python code. But as of yesterday, I had indexers and ingesters for Windows and Mac working. I got the Linux indexer, very, very easy to do, actually. I got it working again today. I only have 3.2 million files on my Linux box. And so I continue to work on this. Evaluating the system really comes down to looking at abandonment. This is going to require a user study. So I'm not quite at the point yet where I've done that user study, but that is where it's going to end up going. And who knows, maybe I'll be asking folks to volunteer. Systems people don't like doing user studies. HCI people think it's no big deal. I kind of have my feet in multiple camps at this point. So I've done the work necessary to have the certification to do user studies, so I'll be doing that. Search time is work in progress, where like I said, I'm doing these basic searches, and this is going to keep growing. We just had a conversation literally just before this talk about what additional searches, what kinds of searches we want to do. And so one of the things that I'll ask you is, hey, next time you find yourself looking for something, drop me a note and say, hey, I was doing this search, because that helps me get a larger collection of possibilities. What should I be looking for? What should I be trying to optimize there? I already talked a little bit about this. The search time when things are in the database are actually astonishingly fast. It was really pretty cool. And the database is far in excess of what could fit in memory. I'm just running it inside of a container on my Windows machine, and so it doesn't have a huge amount of memory associated with it, but it's still able to find things really, really quickly. That really surprised me how fast it was. This has continued to be work in progress. This is going to constantly be a work in progress until probably even after the PhD is done, about how do we make search better? How do we improve this? The goal in the research process is to prove the basic idea. The Unified Personal Index is both efficacious, it helps us, and it is practical. In other words, we can build it without consuming too many resources or having too much cost involved in it. Beyond search, I really think that it will be a key component to allow intelligent agents to help us find things more effectively, to move away from a model where we type things on keyboards and instead move to a model where we actually just talk to the computer and say, hey, computer, I'm looking for files that I shared with Nick last week. Can you show me what you can find? We have the tools to do this now. We didn't have the tools to do this, honestly, when I got started. The tools really weren't there, but they're rapidly evolving. And most people aren't looking at using these in storage. I've been looking at this problem for a long time. This just seems like a really good fit, and I'm excited about it to see where that goes into the future. The cost of storage isn't very big, as I mentioned, 20 gigabytes for 40 terabytes is pretty minimal. The CPU costs so far hasn't been too bad. I've got it containerized. The container tends to keep things fairly limited. I also have a version running on my LAN, both inside of a container and actually on a little Linux box that I have. Works great. And earlier, about a week ago, I did WAN testing on it. I was like, that's pretty cool. I can run this in a virtual machine, run my index, so I could have my devices pretty much anywhere in the world, and they could be sharing access to that. And I think it's really nice to have a single unified index into my Linux box, my Windows box. In theory, it could be on my phone as well. So I could say, I'm looking for this, and like for whatever reason it's on my phone, I can just find it. Because I don't actually care where things are when I go looking for them. I just want to find it. And if it exists in multiple places, the system can show me, hey, it's on your phone, it's on your laptop, it's on your desktop, you shared it with your mother in an email last month. Cool. Other costs include the network cost, not a big deal. So a lot of this is still work in progress, trying to codify those costs. Like I said, I've been expanding the number of places where it's installed and evaluating it. And so far, it doesn't, nothing, I haven't seen anything that scares me. So I think this is going to come out fine as long as the benefit is there. There's a lot of related work. I'm not going to spend a lot of time on it here. People have been working on this for a long, long time. Semantic file systems have been around for, say, Gifford 1991, and tagging was like 2006 was TagFS. So lots of people have been working on lots of variations of this problem. Another area that's similar is what's called provenance, where it's about causal relationships. Where did this data come from? And much of that data is actually generated data. So you have scripts that take an input file and emit an output file, and you'd like to capture that relationship. But those are causal relationships, and that's a subset of the kinds of things that I would want to index, why I'm indexing. So it's not the same as provenance, but it has some similarities, some relationship to that. The third piece of prior work that I would really point to is federated search. There's quite a bit of work that was done in federated search. The idea that, well, we could have a single uniform interface across different search engines. But then it turns out when you dig into the literature, they made all the underlying interfaces the same in order to make it work. There's a really cool issue with the Library of Congress, which has an open source standard for databases. It's not implemented. Every vendor implements it and puts extensions on it. So the idea that you're going to get any kind of agreement in how the search interface is going to look across storage services, it sounds great in theory, but in practice, it's just never going to happen. So just unifying the search interface isn't enough. Even if we were able to do that, we still wouldn't have that extra context that we know will benefit our search outcomes. And that is this activity context. What was I doing when I created that? Where was I? Who was I working with? Finally, I'll point to linguistics. Linguistics actually talks about the meaning of things based upon what they are, semantics. And I thought it was really cool. They also have a concept of the context in which things are used. And that's really what I'm looking at in my research. And that's called pragmatics. And so in many ways, I toyed around with the idea of using the term pragmatics, but it seemed too confusing to the systems community. So I'm just sticking with Unified Personal Index for the time being. Uh, a big motivator for my work was Daniela Viana's work in her PhD was in 2019, and it was this work that said knowing what you were shopping for and knowing who you were meeting with and knowing who you were interacting with on social media actually is beneficial when you start going and searching for things. So in summary, my unified personal index is something that you control that works with local storage, that works with cloud storage, it works with application storage, things that kind of end up like storage, acting like storage engines, but are not traditional storage. It's all personal. It's your data, your activity, and ultimately something that tunes to your mental processes and facilities. The index captures relationships causal relationships, inferential relationships, and augments the mechanisms and facilities of existing storage. We're not replacing storage. This isn't going to be the next cloud storage service. This is something that will allow you to find the things that you've now got scattered around in all the storage locations. And with that, I'm happy to answer questions.
All right. Thank you so much.
Everybody fell asleep.
That's the problem with doing it so close. So we have two hands up, but we also have, I think it's, okay. Let's do, I see Jesse Hall with their hand up. Jesse, do you have a question?
I think I raised my hand last, so I can wait.
I think so. I think other people were clapping. I don't know if they had their hands up. So I think you're good to go, and then we'll get to those people eventually.
Okay. First, I just want to say, as a student in the introductory operating systems class, you were cracking me up with the handler file thing, man. I was wrong. I'm glad I was on mute during that time. As far for my questions, I got two, and feel free to answer one or none of them. One question is, I read something from another professor at Georgia Tech, and he was talking about how to get a good research thesis. And he said, or he wrote something that was to the effect of, you don't really come up with a good idea, you just create good fertile grounds for ideas to pop up. And so if that is the case, then I'm interested in hearing like how you did it, because yeah, stuff like this is fascinating. And I'd love to be able to like create the grounds to get ideas like this. And then my second question is, say you found the perfect system, the perfect model for searching for this unified personal index. What I have a hard time visioning is like what the adoption or implementation of that looks like in terms of like products that we can use on a day-to-day basis, just because I think like with all these, with the big companies and the big vendors, I just feel like this uniformity hurts them in some way that like, unless they all get together and agree, they're going to want to have control. And I see a hard time for that, like getting mass adoption, even if it's for everyone's benefit.
I think that that's interesting. So the first question, I will actually observe that in 1990 I heard Dave Gifford give a talk at the company that I was working at. It was a startup company, and he was trying to pitch us on building the functionality of what he was calling the semantic file system. This is before he published his paper in '91. And at the time, I remember rolling my eyes going, this is completely unrealistic. And it's very odd for me because over the years of working with storage, and I've done a lot of work with storage in the last several decades, I came to this conclusion that we've created a complete goat rodeo, to put it politely. And some of this is exactly what you just said for your second question, or the point you made in your second question, which is the storage vendors have absolutely no motivation to solve this in a cross-platform sort of way, because what they want to do is capture you. They want you locked into their storage solution. And what that realistically means, again, I'm maybe this isn't the case for other people, but I don't get rid of storage services. I just keep giving them their $100 a year and say, because I don't really want to deal with trying to move it to someplace else. Did I address both your questions well enough there? I don't know, because it was long and I might have easily dropped something.
Yes, I appreciate that. Thank you.
Hey, no worries.
So I think next would be Kyle, or at least I'm just going top down here.
Thank you. So my question, I have a background in math, and And when I think of a search, and I know you don't like searches, but when I think of a search, one of the things that I kind of expect from the search is to use various distance functions.
Absolutely.
And so I was wondering, did you work at all on that to define this distance function? That's saying like, you gave this example where you give it like some semantic context for what you're searching for. Like, what was that thing I was working on last week with, Fred? Now, there's a good chance that I don't know about you. I work with dozens of people every week, a dozen different people, or dozens of different people. I mean, I very well would get that wrong sometimes, and I would need my search engine to, create a distance function, like to have some notion of distance, where it's like, well, Fred is in the same group as Carrie, so you might be looking for a Carrie that's like a 0.8 away from what you asked for, like assuming that the distance is 0 to 1 or something, So does that make sense? I'm just curious if you worked on that with your index, your universal or unified personal index.
It absolutely makes sense. I mean, I have an undergraduate degree in mathematics, and one of the professors that I still remember his area was Lie algebras, and I don't know if you know much about Lie algebras, but they are the underlying basis of fuzzy logic. And fuzzy logic is used for exactly this kind of how close am I kind of analysis. You're familiar with Levenshtein distance, for instance. That's used in, when you go to Google and you start typing things in, or you mistype something and it still searches and finds the correct thing anyway. That's a Levenshtein distance. So this is a huge issue. Pretty much everything you put in a graph, and I think of graphs as being mathematical objects. I just had an interesting conversation about this before this talk, and I think of everything. Yeah, so graphs can have weights on their edges, and in essence, that becomes a distance function. So everything is a metric, and everything is how close is this. And in fact, when you start looking for things in this very large graph, what you end up doing is, in essence, creating hyperplanes and trying to find things that are close. So you're doing K and N because you want to know what's similar to this across multiple vectors. And as you point out, sometimes people get things wrong. And so it becomes a question of, okay, what's the Levenshtein distance between Aki and Saul? I mean, because I met Aki and Saul, I met them both last week, but not exactly at the same time. Maybe I'm misremembering it. So you might give Aki a smaller metric, a smaller distance than Saul, but you might say, well, maybe it was Saul too. And I don't have to solve all those problems. As a systems problem, what I have to do is provide a framework that makes it easy for other people to solve them. And that is actually one of the fun things about this, is that I can see this building a space or an environment for other people to come along and say, hey, cool, I can drop a classifier in here. I can drop a semantic transducer in here. I can add some other weird kind of activity context that nobody else has really thought about. I'm bored one day and I can go to Hugging Face and grab a model and slap a front end on the model. I mean, I was thinking that it would be really cool just to have a simple transducer that walks through all of the things that could possibly have EXIF data in them and pulls them out of the files and puts them in your index where they're useful. Because if you have to go and find all of the pictures you took with a particular camera, brute force search sucks. It really does. And so if I can index that and put it aside, isn't that really cool? And so enabling additional work in this area is a lot of what I'm hoping to be able to accomplish with this research.
That is really interesting. So like you're building like this very generalized framework for others to develop these new distant notions of distance. They will be incorporated into it. I'm curious. Oh shoot.
I think we have a bunch of other questions.
Yeah, so. I'm sorry. I didn't mean to.
Yeah. So Wengxin, Wenxin, Wengxin.
Yeah. Hi. Hi, Tony. So, I think one of the takeaway is that your indexing system is running locally so that you can protect some sort of data privacy of the user. I think it's also interesting you mentioned how a large language model can be incorporated in this system. I'm just wondering, what's your take on like the use of LLM if it's integrated in terms of the computation resources as well as data privacy? Because we know that LLM has to be running probably in third-party cloud because it uses a lot of GPU to do inferencing and
I'm not sure I'd agree with that last statement. There's a huge amount of work that's already been done that has even reduced the amount of time and energy it takes to do model training, which is the compute intensive part of that. But and so I think there are going to be improvements in that area. There already have been improvements, and I think that's going to continue to improve. It may also be one of those cases where you have to decide what you're willing to trade off. So when you buy an enterprise license, for example, to the OpenAI API, those licenses do not give OpenAI the right to use the data that you submit to them. So somebody's paying for that. And that is always an interesting question. I mean, I've talked about this being personal. You said I keep it local. I was pretty careful to say that it was always under the user's control, but I've already created an index database on a public-facing machine where I wanted to be able to demonstrate that I can do that, but I control that machine. As long as I control that database, I have some measure of management of that. In terms of using LLMs, yeah, I don't know what the right answer there is. I think it's going to continue to evolve. And it may just be that if you really value privacy, then you pay for it. And if you want the service, but you're willing to give up some anonymity for it, then you get it for free. That seems to be a common trade-off. I've taken a very strong, I'm protecting all of this data approach right now because one of the common attacks that I get on this research is, oh, but what about privacy? And I don't want to deal with privacy in any great depth until I can prove utility. I have to prove this is useful and it's achievable before I then say, let's now go spend some time making this private. But I think it'll happen.
Okay, yeah, thank you very much.
Next we have Elan Michael.
Elon. Yeah.
Elon, sorry.
Hey, cool. Hey, Tony. Yeah, great presentation. Made me think a lot about how I use different systems and even just like just really the context around that. So my question was, a little bit of two-part, but I'll make it short. Like in terms of these contextual systems, you mentioned like sound or microphones. Do you know of any like research in trying to like solve this other problem, which is what's the whole context around my entire day? Because, there's that part where you're saying that, well, what was the document that I got before I went to grab coffee? But then the other question is, what was I doing after I grabbed the document? Right? So there's a separate world out there.
Yeah.
And so there might be some interesting research. And then the other thing is, how do you, define the scope of what you're willing to look into in your PhD, for these topics of like, obviously you don't want to like, try out every type of contextual system to help, build your index, but you need to at least look at some of them, to be able to verify your hypotheses. So where
Right,
do you draw the line?
and there's a balancing act there. So what you typically end up doing is you say, look, here's a whole space that I could study. I'm going to pick one or two examples out of that. So for instance, we were having exactly this conversation today. It's like we want to come up with classes of searches and then pick one, implement one example out of the class, and then say these others are really more about engineering effort. That's not a research question. That's not the key thing to analyze here. I've been pushing pretty hard on getting a single index with my Linux system and my Windows system together because, number one, you don't see a whole lot of work where people have heterogeneous operating systems kinds of efforts, and I think that's kind of cool. And number two, you don't see a lot of systems where the indexing is available on both systems, but is common, is across them. So it suddenly unifies them in a way that we haven't done before. So that's a nice thing to present as a research contribution, to say, look, this is actually useful. And people can say, well, yeah, it's obvious that it was useful, and okay, great, but nobody actually demonstrated that fact. But yes, you always have to make that trade-off. You always have to say, I don't have infinite time and resources, and what I'm going to do is I'm going to build myself a prototype that demonstrates that the basic idea is a good one, and then I'll go raise some capital and do a startup company, and we can build it into a production system.
Speaking of not having infinite time and resources, Tony, are you okay for a couple more minutes
Yeah,
just
I'm
to
fine.
wrap up the
I'm fine.
last?
It's only 6 p.m. for me. It's 9 p.m. for some people, or maybe even in the middle of the night for others. I don't know, because I do remember from the OMS program, I always was amazed that at least like in GIOS, I could literally be on Slack and there were like 25 time zones, people scattered all over the world. It was really cool.
Yeah. So, okay, if we're good to keep going, next up is Caitlin.
Hey, thanks for that awesome, very thoughtful presentation. I am an HCI, and my background is in HCI. So I think my question will be sort of in that vein. And I guess you said a couple of like very digital humanities sounding things to me.
Oh no, I'm gonna lose my
Well, it's cool.
I'm gonna lose my systems credentials if I keep doing that.
You said something early on about I don't know if I want to call this search. What I really want to call it is finding. And then, I thought that was really interesting framing. And you also said, oh gosh, there's something else that really stuck out to me. Oh, I had a note about it. Of course, I lose the clarity of my thought in the middle of the question I'm asking. But so I think my question still stands. You're learning a lot about human cognition by doing this work, it seems. Like the way that people decide to sort of solidify an idea, when somebody chooses to save an idea, how they're trying to access it. And I'm wondering, what are the journey maps that you're considering? What are like the user journeys, the trajectories, and like what are the inflection points along those user journeys that are causing you to pause and think? And then if I might sneak a trailer it's just maybe, what if what you learn here is about helping people to make better decisions about how to save a file or when to save a file, or how to use these limited resources that we have more effectively? What if maybe that ends up being part of what you can offer with this work that you're doing?
I think that would be really cool. That's not an area that I've explored a whole lot. I will, there was something you said early on, and I want to touch on this because I think somebody else commented on this. Okay, so I actually don't care about search, but what I do know is that the literature is really deep, that search sucks for humans. And so you're coming from an HCI background. There is a study in Nature where they did brain scans of people doing search activities. It uses different parts of the brain than navigation activities. That literally, when you do search, it uses your speech centers, and those are high cognitive load. The reason that people will come and ask you a question that you turn around and type into Google is because they don't like to search. It requires a lot of cognitive load. Having a conversation with a personal archivist would completely change that model, because instead you'd be interacting with them. And so you'd say, show me files that I shared with Aki. And you didn't share any files with Aki last. So it must have been somebody else. Who else did I meet with that I might have shared files with? And say, well, you shared files with Saul, and you shared files with Nick, and you shared files with Caitlin. Oh, okay. Oh, maybe it was Caitlin. Those kinds of much more natural interactive conversations, I think, would really be helpful. You also talked about efficiency. One of the things that Ada talked about last week, I meet with her every couple of weeks, was this thing where she literally saves her old laptops. And she said it would be great if I could just simply say, where are these things? And it could say, oh, well, you happen to have a copy on that old laptop and on your current laptop and on the laptop before that. Um, I don't have any way of doing that right now. I mean, I do kind of the same thing. Anything I want to save, I copy to the next computer up, and then I keep the old copy sometimes around or not. I know I have duplicates. I know it. There's duplication all over the place, but I couldn't tell you where they were. Having even just this index would allow me to do that, and that might make it easier for me to safely curate things. Another thing that it would do is eliminate the fear that I might accidentally delete something I still need. The system could tell you, well, actually, you've got 4 copies of it.
Yeah.
You might be able to build automated tools that would say, do you need to save space on your OneDrive because you're hitting the tier limit? And you can say, yeah, well, you've got these things that are also duplicated in these other places. And you can say, oh, great, just clean those up. So that's a completely different set of utilities. It's not search at all. It's much more about, that's like curation. So you could build
Definitely.
curation tools. And I think that would be really awesome.
I do too. Cool. Super cool. Thank you.
There are also questions that people typed into chat. I don't want to cheat those folks out.
Yeah, I think actually there was a person, I think Travis actually is the person who has their hand up and the most oldest person who also put their question in chat.
I don't think he's older than I am, but
Yeah.
I probably am. But I put my hand up just to represent those of us in the chat.
Yeah, it's all cool.
Yeah,
I
so-
actually saw your question. I thought it was pretty good. So Travis's question, in case you aren't reading it in chat, was, where am I in my PhD timeline? Well, I'm told I have to finish by the end of August, so I'm doing everything I can to get it done by the end of August. How do I plan to use this past my PhD? I'm not sure yet. I mean, I decided that I was going to do this PhD before I died, and so as it got closer, I decided I really had to get this done. I didn't do this because it was going to somehow further my career. I think that makes a lot more sense for somebody who's early in their career. If you're doing it late in your career, it's much more of a personal undertaking. Financially, it's a terrible decision, but it's also freeing in that you get to research something that might make a difference, but at least it gives you the opportunity to explore, and you're not going to get that very often in any other endeavor, to spend several years really working on a hard problem. Am I going to continue researching and staying in academia? I might. I'm not entirely sure yet. I really enjoy teaching. I've been teaching a course here at UBC called Distributed Systems, and I really have enjoyed that quite a lot. It's very time consuming though, and honestly, teaching while you're doing a PhD isn't, again, the brightest thing to do because it takes a lot of time to do it and to do it well. I have also considered whether or not there's a viable startup company here. I do think there is. I think that this could be a very interesting product, and part of what I was mentioning before is the way to do this is you build something that you can let individual people use for free, and you try to convince them that this is the greatest thing since the paperclip, and then they go to their company and they go, you guys, we should be using this here too, and then you sell it to organizations, and that's a very traditional kind of systemsy startup sort of model. But we'll see. I don't know.
Thank you very much.
Junsu in the chat asks,
Yes.
when there's a lot of literature and related work that seems promising, how exactly do you focus on research, formulate specific research questions, and prioritize what to include, exclude, or how do you determine what is the best thread to pursue at the time? Do you have a general heuristic or strategy?
Well, you can see that one of the things I specifically touched on in my talk was, gee, look, here's all this prior work that's been done that butts up against this tangentially. I would say that there's a variety of techniques that I use, one of which is when I find something that I think is really close to what I've done before, I say, how does what I'm doing, how do I distinguish that from what's been done before? At this point, I don't run into that very much, but I have run into that in the past where people have said, oh, well, so and so did this. Placeless, which was a Xerox project in the late 1990s, actually did some limited form of activity context where and I mentioned it very briefly on the slide, but I didn't talk about it in the talk, where they associated the way that an application used the files. So they kept track of the application to file relationship. And that was some pretty cool work. It was a very interesting piece. And one of the papers I submitted got rejected because one of the people who reviewed it had worked on the Placeless project, and I didn't talk about Placeless. And so, if you miss things like that, you're going to get a rejection and you're going to have to deal with it. I dug into that and I said, it's not the same. Provenance. I had somebody ask me, well, how does it differ from provenance? That's why there's a slide on provenance there. I had an answer for that one. That was a poster presentation I did last year at Eurosys, and I had an answer for it. And the person was like, oh, okay. Yeah, that makes sense. It's not just causal relationships, it's also inferential relationships that we don't currently capture at all. There's no single recipe here, though. You really do have to kind of keep reading and keep looking, and then sometimes you take inspiration from other fields. There's another question further down about vector databases, and I started looking at vector databases about 6 months ago, and I said, I think there's actually going to be a place and a time to use them, but it's not right now. I heard a research talk about comparing various vector databases on last Friday, and it was really interesting because I really understood a lot what they were talking about because I've been looking at vector databases. And vector databases are really useful for solving a particular class of problem, not the least of which was that metric-based, the locality problem. The weighting or the measure of how far things are apart. Vector databases specialize in doing that in high dimensionality spaces. Activity context definitely feels like it could quickly become a high dimensionality space. And so there will be a time when throwing a vector database at that might make sense. But the most common use of vector databases right now is actually in full text search. And this came up about a month ago. It was like, oh, well, what are you going to do about full text search? And I'm like, I'm not interested in full text search. There are very good full text search solutions. So today's conversation was, well, maybe we should pick a full text search solution and see how we would wet it to this index. And it's like, yeah, actually that makes sense, because if I could find a document or a set of documents that were of interest to me through the full text search, it would make sense for me then to have some way of figuring out what the original sources were and looking for other related materials, not based upon their textual content, but based upon their usage content or their associative content. When we organize things in the file folder metaphor, often files that are co-located in a particular folder have some sort of relationship, even if it's not a direct relationship. And being able to go back and mine that and use that to find other potential useful information could be quite handy. So you constantly keep looking for these things. You always have to be reading papers, and you always have to be talking to people, and you have to present your work like I did here this evening. I said, this is what I'm doing. And you're going to get people who go, wow, this is really cool. And you're going to get people who are going very blasé about it. Like, I don't know. I don't have any problems. And I get this sometimes too. I don't have any problems. I can always find everything. And that's great. I mean, it's cool. But I would say that that's probably about 10 or 15% of the people I talk to. So could be a confirmation bias too. I only talk to people who want to agree with what I'm doing.
I think just for timing's sake, let's do maybe two more.
Sure.
I'm just going to go down in the order that we have here. So VCAS writes, how will it be different from an inbuilt OS index search in case we are limiting search only to personal data?
It would be only personal data that's on that particular device. Currently, those the index services like Windows Search, Spotlight, Linux has some as well, only index things that are local. They don't do anything that's in the cloud. So if you really do only live on your local device, you don't need this system. The system isn't solving the problem that you have. The existing search facilities are fine. They're extensible. You could build some of these add-ons. It still wouldn't necessarily integrate the activity context idea, but there's nothing, the benefit of doing this research and presenting this work is that if this were useful, then Windows Search could easily incorporate activity context into their own search mechanisms, and Apple could easily integrate that into Spotlight. I think it's great. I think that'd be absolutely wonderful. But for the majority of users, not everything is on a single device. Things are in the cloud. Things are on USB sticks. Like how many USB sticks do I have kicking around? And it was like one of these little annoyances. I said, if the index would just tell me what brand it was and what size it was, I could probably narrow it down. Otherwise, I have a bucket full of USB sticks that I've collected over the decades, and I'm never going to go through all of them to find something. But if I could narrow it down to 3% of them or 5% of them, I'd go through 3 or 5% of it if I really needed the file. Simple, but possible. So I don't think local indexes don't actually work with those kinds of devices typically, because they couldn't tell you anything about the device because they're not collecting that. They could. I'm not saying they couldn't, but I don't see the local index service right now on your local machine as solving the larger problem.
And I think you touched on this one, but just in case, how might UPI enhance the capabilities of current vector databases, particularly in the realm of semantic search and semantic data retrieval?
Okay, so semantic search and semantic data retrieval are concerned specifically about the intrinsics of the file. What does the data in the file represent? What do I know about it? The idea behind the UPI is that you can, in fact, store semantic information in there as part of the indexing, but we're not limiting ourselves just to semantic information. If all I was doing was semantic information, I'd be getting rejected because this is just the semantic file system 30 years later, 33 years later. Instead, what makes it interesting is that it uses semantic information, but it also then builds on top of that this idea of activity context. And the combination of the two actually will be they're powerful. It is actually very powerful to be able to say, I'm looking for files about this that I shared with somebody, or that I was in, I don't know, Kuala Lumpur when I created, or I was listening to this song, or I was meeting with this person. And those two together really help. The problem with almost all of the indexing is that you have to make decisions to narrow out the fields to try and get down to the specific things you're looking for right now. Google taught me a very important lesson, and that is you never want to return more than 10 things, because nobody's going to look at it beyond 10 things. You remember one time reading that if you typed the term Jesus Christ into Google, it would give you billions of entries back. And indeed, it actually does. And if you go to about page 18, it says, all the rest of them are the same. So Google says, yeah, we returned billions of answers in 0.2 seconds, but we're really only returning 10 of them. So it's narrowing those things down. This isn't a search problem like Google's trying to solve. This is a search problem of I need to find a specific thing, because not finding it will cost me time and energy, because I will have to keep searching or recreate it.
And I think with that, we'll wrap up here. But Tony, thank you so much for being 20 minutes over, answering more
I get to
questions.
talk about research. I could keep going on for hours at this, and they'll be bored.
Well, I think we'll cut it off here.
Yeah, absolutely.
But I truly appreciate you coming. Thank you so much for this talk and giving a slice of your research, and best of luck. Best of luck defending. I know that that was, for me, a big thing to work towards. So congratulations on marching towards that, and best of luck in whatever comes out next.
Thanks, everybody. It was great to meet everybody, and feel free to drop me a note. I probably should have put my email address on the slide somewhere. fsgeek@gatech.edu works, or fsgeek@cs.ubc.ca. That also works. So thanks.
All right. See you, everybody.